All right, so we talked about the exam. I'll let you guys know, I think we should be able to hold at least one review session after the study day because the exam is rather late in the exam period, so we can definitely do that. I'll keep you posted. I'll give you guys some example question as well for you to get prepared. I don't really have the entire past exam, but maybe some example questions. But in the review session, you can also feel free to ask me or the TA any doubts you want us to clarify. I'll keep you posted. And then for tomorrow, it will be your written test number 2. It's going to be over e-class, so please make sure your PPY and EECS logins both work like last time. You will need your mobile phone for the dual mobile verification, right, in the beginning. And everything has been released to you, especially the review session from yesterday. I thought it's a very nice and thorough session. So you haven't got a chance to check out, it's a really nice way to really go over certain topics. I think Micklin did a very good job yesterday. So you can feel free to check it out. It's on the lecture site. Your lab number 4, there has been a grace period until midnight today. So please make sure you submit it in time. If you haven't done that, I will release the solution walkthrough for lab number 4 tomorrow as well. And also, I will give you guys some guidance about programming test number 3, which will happen next week. But I can already tell you right now, the programming test number 3 is going to be solely based on lab number 4. Inheritance and also some OOP kind of stuff that you kind of do in the lab. Right? Also, as usual, we'll give you guys some practice tests as well by the end of Monday. And next Wednesday, you can also expect another review session just to help you some parts of the solution. All right, guys, any questions about the course? So the idea would be, so today and possibly about half or maybe 2/3 of Tuesday's class, we're going to finish off the inheritance. So we have covered quite a bit about inheritance. You can see we try to go very deep into not just variable assignments, not just about using super and extents. We also talk about typecast and also about different stuff like a class cast exception. When I do the recap, I'll kind of highlight the stuff you should really know before writing the test tomorrow. But today, we're also going to continue with the discussion. There are still 2 things we got to talk about inheritance. One will be about the instance of operator. The other one will be about polymorphic collection. Polymorphic collection is really the place where we put everything together. It will see the real value about doing inheritance. That's something we'll do. Maybe not today, but most likely maybe Tuesday. And after we finish off the topics on inheritance on Tuesday, we'll do the last topic for the course, which will be recursion. So that's going to be more like a transition to the follow-up course to this one, which will be 2101, the data structure course. They definitely assume some basic proficiency about recursion. So that's something I will cover stuff in the lecture. I will give you guys some challenging exercise to do, also can get you prepared for the exam. And also I'll give you guys some past lab. You can also try to do them as well, just to get your recursion properly exercise. It's not just for this course, it's really for the follow-up course as well about recursion, right? I'll keep you posted about the material. All right, any questions? All right, let's now do some quick recap. All right, so we definitely got more and more interesting stuff about inheritance. It's a very fun topic. Just try not to really just memorize the rules that we talk about. They do have some logical reasoning behind. If you really try to appreciate how things are done, it's quite a fun topic to really study for. Okay. All right, so let's now talk about quickly what we spoke about last time. Sorry. There we go. Okay. All right, so last time we spoke about the motivation for typecasting. Basically, if Jim over here dynamically is really pointing to some resident students, however, we cannot really assign Jin to something that's expected on resident student. We cannot do it simply because the rule tells us the static type for Jin is actually student, which is not the descendant class of resident student, right? So that's something you guys should be very familiar with for tomorrow. However, if we're really sure dynamically this is really resident student, we can do typecast. Also, in yesterday's review session, your fellow student actually asked a very good question about typecasting, right? So you learned maybe in 1021 or 1022 about typecasting. You are trying to cast from double into integer. And you're using exactly the same syntax. And also compare with the typecasting we're doing here. So there is a critical difference between that. You can check out the recording from yesterday. So we had some nice discussion about it. Okay? It's also good for your knowledge. All right, so that's exactly the scenario we want to do typecasting, and this page here is only for you guys' information. I just want to say that again. It's really for your knowledge. So there are many things that computers simply cannot solve. A category of problem that computers simply cannot solve would be to infer the runtime behavior of another program. So whenever, if you're given a problem to solve, and the problem is to really infer or analyze the runtime behavior of another program, most likely it's undoable, right? Just something for your knowledge, it's undecidable. So this is why typecasting exists, for us to have some workaround to actually do things at the runtime. All right, but we'll get more to the typecasting today. All right, so that's the anatomy of the typecast syntax. I want to just point out again, number one, Jin is the variable we want to cast. So Jin is already pointing to this object. The typecast does not modify this object here. Also, it does not modify the static type for Jin. Nothing. All typecast does is to add another alias right here, pointing to the same objects. And that alias has the static type corresponding to the cast type. That's all we're doing. We are not modifying anything. We're just creating an alias. Okay? And then, so you really want to understand, after this variable assignment over here, you actually got 3 references in total. And you can check out the recording from last lecture to see why the 3. One more thing to also emphasize, when you actually have some cast expression. So this expression here is a cast, which will cast from Jin to resident students. So what's the static type for this particular cast expression? It will simply correspond to not a static type for Jin anymore, because we're doing cast. So the static type will be the resident student, the cast type, right? That's also something we mentioned as well. All right, and then we did a also we talked about anonymous cast. It's simply just a cast without any name to it. And I'll give you guys more example today once we talk about instance of operator. It's actually quite a nice way. Sometimes you're doing typecast maybe only for certain method call temporarily. So you don't necessarily have to create a name for that. It's completely your choice about whether you want to give a name to the cast or you don't want to give a name to it. Completely up to you. And just remember, if you forgot to actually put the parentheses around, it's actually wrong, right? We talk about it, why it is wrong. You can also go over the reasoning from last lecture. Okay, so let's see. I just want to get to the class cast exception, right? Let's now recap about class cast exception, okay? Whenever you see a typecast, there are 2 things you are concerned about. Compilation as the first stage, and also runtime in the second stage. If the code compiles, you can talk about runtime. If the code doesn't compile, you don't even bother. There's no runtime. All right? How can we judge if the typecast should really compile? As long as it's either an upward cast or downward cast, it will compile. If it compiles at a runtime, you may or may not run into the class cast exception. And to determine if you're going to run into class cast exception, you have to look at the dynamic type for the objects, right? So that's a very quick recap. And we did many examples in the lecture. I think Minklin, the TA, she also went over certain exercises that we didn't quite do in the class. You can also look at them. She also went over with you some solution. And also she added some questions about typecast also to your practice test as well. So check out the video. I think it was very good from yesterday. All right, so guys, do you have any question about class cast exception? Okay, yes?
For the code line, where we know that there will be a class cast exception, right? But we still draw something, right? We draw that because this is compilable, right? So the variable, for example, in this one, line 2,
yeah.
and RS, right?
I see what you mean.
So for the RS, what we can say that dynamic type is the one which we are pointing to or not?
I see what you mean. So let's go one by one. Okay. First of all, I assume you guys know line number 1, 2, and 3 compiles. So we can now talk about runtime. All right. For runtime, we're going to execute line number 1, number 2, number 3 in this order. As soon as some exception occur, we're going to disrupt the execution flow. Line number 1 is going to correspond to Jin pointing to some NRS objects. So that one can be done properly. When we try to execute line number 2 over here, we're trying to do some variable reassignments. Before we know what should be reassigned into, we got to do this typecast first. So when we try to do this typecast, what we attempt to do is to create this particular alias with this particular static type. That's what we're trying to do. However, when we're trying to do it, we're going to run into trouble, right? So this, okay, I see exactly what you mean. So maybe more precisely, I should have put a question mark over here. Can we actually create this alias at the runtime? It turns out we cannot, because the dynamic type here cannot fulfill the cast type. So this cannot even be created, so we got some class cast exception. Good question. All right. And then another of your fellow student also asked a very nice question from last time to say if the subclasses C1 and C2 simply are identical at the moment. Let's say they didn't create any new methods or attributes when they are first created. In this case, can we say C1 can fulfill the expectation for C2 since they are identical? The answer is no. Compiler, again, is not that smart. All they check would be, they only check to see whether C1 is a descendant class of C2. If it is, you can say C1 can fulfill C2. Otherwise, it cannot, right? They only check for like a descendant class relationship. You can also take a look at the discussion from the lecture recording from Tuesday. Okay, and then this diagram here is extremely important. This one here really try to tell you that given certain inheritance hierarchy, you got so many classes over there, and you start with certain reference variable, let's say my phone, and it has some static type which never changes, which is here, Android. From this static type, you can do either upward casting or downward casting. So these are the compilable cast, which will compile. And then we can talk about runtime. And these are neither ancestor nor descendants, in which case there's no runtime because it doesn't compile. In the cases where you got upward cast or downward cast that compile, and then we talk about whether or not the cast is actually can succeed by creating that alias. If it fail, that means the dynamic type, this is where you should really talk about dynamic type and consider it. If the dynamic type of the reference variable cannot fulfill the expectation for the cast type, in that way, you're going to run into class cast exception, right? So you guys should really look at this diagram here. It could look a little bit complicated as a final product, right? You may want to look at the build up for this diagram. It really shows to you about the thinking process, right? That's really what you should know. Of course, this is only for smartphone hierarchy. In the written test or in the exam, you may have to deal with a different inheritance hierarchy of different shape, or maybe with different classes, number of classes. But the principle is really just the same. Yes?
Question is on expectation.
Yeah.
When we are mentioning expectations for specific class, if we have overloaded methods.
Overridden method.
No, not overridden. My question is if we have overloaded methods.
Overloaded method, okay?
Yeah, do we count them as different methods?
So, yeah, I see what you mean. So your fellow student was asking, let's say for example, right?
Yeah.
Let's say in the smartphone class, we got M1 that takes some integer I. We also got N, that's the same method, that takes maybe a string, S. So these are considered two different methods, of course. Yeah. So when we say different methods, just based on the name, and also you can think about like a header, the header of the method, which would be the name plus all the parameter types. Okay. Yeah. All right, that's good. Okay, and that's the final exercise we did. This is just the main lesson from this exercise here is you can cast from one type into another arbitrary type by simply upward cast and then downward cast. For example, if I want to cast from B to D, they have nothing to do with each other. If you cannot do in a single step, but you can do upward cast and then downward cast. Compilation-wise, you can always make things work. However, you are still going to pay the price at the end. So for example, for this particular expression here, it's going to compile. You do upward cast followed by downward cast. The upward cast itself will not run into any class cast exception. However, when you do the downward cast, the dynamic type C cannot fulfill the cast type D because C is not a descendant class of that. That's why you run into class cast exception. All right? So you may also want to follow up the story about what we said on Tuesday, just in case you still have doubts. I think Mikkelin also talked a little bit more about this kind of basically the same example, but just based on the scenario for your practice test yesterday. You can also check out the review recording. Okay? And that's about it from Tuesday. Any questions? All right. So today, I want to talk about the instance of operator. I want to talk about it, do lots of examples with you. I'll go a little bit systematic, but a little bit fast. But hopefully it's not too fast. But you can always slow me down if you want me to. So let's talk about instance of operator. I'll give you guys some detailed notes, and then we'll do some visualization, and then we'll go from there, do example. Okay, instance of. Okay. So what we talk about is there is a keyword in Java, instance of. It's a single word, no space, instance of. Okay, spelled exactly instance of. It's a binary operator, meaning that you have a left operand and a right operand. So you got something on the left, and also you got something on the right. Okay. The right-hand side is very straightforward. It's simply a class name. Let's just say Y. Okay. And then the left-hand side is an expression. I'll give you some example right away, but let's say it's an expression denoting some object. It should be a reference type objects. Denoting some objects. For example, could be as easy as, I might just say X, where X is a reference variable, or RS, or NRS. Or it could be, for example, a particular element in the array. Or it could be some array A at index I. That's also possible. As long as the expression there is of some reference type, then it can appear on the left-hand side of the instance of, right? So make sure you get the order right, okay? All right, so that's the syntax. And we'll see lots of examples, so don't worry. I just want to give you some, summarize about what it is supposed to do. Number one, this is a Boolean operator, a little bit like a conjunction with disjunction, right? So it's going to return true or false. So this evaluates to Boolean, which means it's going to be either true or false. Okay? And let's talk about what it means when it returns true. True if, okay, I'll give you several things over here. Okay, there's different ways to really interpret the result being true. If it is true, oh, you know what, for here, why don't I just put just X? Okay, just X to make it easy. So we are saying, if I say X instance of Y, when would it return true? Okay, it will return true if the dynamic type of X right here can fulfill the expectation of Y, right? So think about the X is the X over here, and the Y is the Y over here. As soon as I talk about this pattern here, you might notice this is something I kept saying all the time on Tuesday when we talk about typecast, right? Okay, I'll get to it, just in case you already find some familiarity. If that's what you're feeling, that's great. Okay? So one way to interpret the true result is dynamic type for X can fulfill the expectation of Y. Let's make it more like a rule. Rule number two, dynamic type of X should be a descendant or ancestor of Y. Descendants, right? Good. Right? You can see the pattern here. Once you see one, everything else should really follow, right? Is a descendant of Y. Okay, again, let's just make it very explicit here. And let's visualize this. What that means is, if I actually got, let's say, X is a reference variable, it is pointing to some objects, and that one has some dynamic type. you can think about this will be X's dynamic type. And we're saying that for this particular dynamic type, it's a descendant class of Y. So you can think about this class over here is somewhere in the hierarchy. And then along its ancestor path, somewhere, you will see Y. Right? So this tells you that X's dynamic type is a descendant class of Y. So that's why dynamic type can fulfill expectation for Y. Right? That's how you visualize it. Another way to say that would be Y is an ancestor of the dynamic type of X, right? Just in the reverse way. Okay, so this one here, X, and then you got Y, right? I would suggest understand point number 1 first, and then 2 and 3 will just follow naturally, right? Now, question for you. Maybe some of you can already answer this because you got tests so relevant to this for tomorrow. Oh, by the way, tomorrow we don't really cover instance of, right? I'm just saying, in order for you to understand instance of, you should know what you're supposed to know for tomorrow. If I know that X instance of Y, what does that allow me to do? Again, okay, now I will help you a little bit. If X instance of Y returns true, that means the dynamic type of X is guaranteed to satisfy the expectation of Y. That means I can cast X into Y without worrying about having any class cast exception. Because I know that if I try to cast X to Y, it will run into a class cast exception if X dynamic type cannot fulfill the expectation of Y. But instance of being true tells me that I don't need to worry about that. All right, that's the kind of logic here. Okay, I'll write it down. Okay, and then let me just write down one thing again here. Okay, so if the result is actually true, then it is safe. Well, safe in the sense that we don't have any class cast exception. Class cast exception to execute. Okay, let me just say the cast. Okay, so X cast into Y. Okay, the type cast, right? Again, you can see the Y here. So X here and Y here. Let me try to talk about it backwards. We learned from Tuesday. Whenever I got any cast expression here, I'm going to run into, compilation-wise, it will work if the static type for X is either doing upward casting to Y or downward casting to Y. Assuming that it compiles. I'll run into class cast exception if the dynamic type of X cannot fulfill the expectation of the cast type Y, right? And now instance of checks exactly this. Before you do this cast expression, check to see whether X's dynamic type can fulfill expectation for Y. If that returns true, then go ahead, do this. If it is false, you better not do it. All right? So that's a way to really have some safety net for your class cast expression in your code. So that's why you will see quite often in people's Java code, especially they got heavy inheritance usage, they'll get instance of check all the time. One of the usages is to make sure before you do any cast, make sure it is safe to do so. Well, we'll see an example like this. And in your lab number 4, I know it's a little bit late, but anyway, so you will see that when I release the solution tomorrow, you will see that I also use an instance of operator to check the dynamic type as well. So you can check to see whether it's a monitor or follower, for example. Right? All right, so that's a very important just definition page just to make sure you kind of got it. Let me do another definition page, right, just to complement this, right? It's more like a visual. Okay, this one here. So this one here put the instance of more into the context. Okay. So I'm going to talk about these 3 lines. 1, 2, and also 3. Line number 1, we are simply creating some reference variable, static type A. dynamic type B. So once we got these two fixed, we can somehow define all those categories, right? About compilable versus non-compilable, class cast exception versus class cast exception not occurring, right? Right? So these two are important, right? A and B. And we know that line number 1 should compile if B can fulfill the expectation of A. That means B should be descendants of A. In this diagram, yes, it is the case, right? So line number 1, we are fine. Okay. I'll talk about line number 2 in just one moment, right? That's something we just learned. I'll get there. So typically, if I want to do some typecast, right? So let me just put it here. This one here. So just remind you very quickly. This one here compiles if it's either upward or downward cast. That's point number 1. So whether or not it should be an upward or downward cast, you got to look at the static type for OBJ, right? Upward cast can those go this way. Downward cast can go this way. And how about here? Neither ancestor nor descendant. So it's neither upward nor downward cast. So it should be non-compilable cast, right? It's about compilation. Number 2, let's say it compiles. So now you can talk about runtime. So number 2, okay, I'll put number 2 here, right? So number 2, at runtime, there will be no class cast exception if the dynamic type for OBJ, the microphone died actually. Can you hear me from the back, right? Okay, yeah, just in case you cannot, okay, always repeat. Okay. So there will be no class cast exception if the dynamic type for OBJ can fulfill the expectation of this particular cast type. I'm making that question mark so we have a range of possibility to talk about. All right. If OBJ cannot fulfill the expectation of the question mark, i.e. OBJ, oh, sorry, there'll be no class cast, I said it wrong. There'll be no class cast exception if OBJ can fulfill. Okay, you just got it wrong. I beg your pardon. Can fulfill. Just be careful. Can fulfill. Right? If you can fulfill, there's no class cast exception. If you cannot fulfill, there will be class cast exception. Okay? So that means OBJ is a OBJ's dynamic type is a descendants of question mark. All right? You can think about the question mark over here is really the cast type. Okay, and then when you talk about the dynamic type, it's really B. Okay? Right, these two things you also know. All right, so if you look at the description for line number 3, that's exactly what we have, right, from before. So now what we're doing is we will only know about the dynamic type of OBJ when we get there at the runtime. So the best way to really protect for us from any class cast exception is to wrap this particular line and make it conditional. Meaning that if at this point OBJ's dynamic type can fulfill question mark, cast type, then we'll do the cast. If it cannot, we don't do it. So that's why we put in this particular if conditional. We only check right before the cast. So this condition here, right? So this is checked. Right before an attempt to the cast. And as we actually learn from the definition, you can get yourself more familiar and then you can come back here, right? So based on the definition here, this Boolean condition here is going to be true if the dynamic type of OBJ can fulfill the expectation of question mark. That's exactly what we said here about no class cast exception condition, right? So if this is true, then we actually can do the cast without any problem. What if it is false? Then we simply bypass. We don't even execute it. So if you don't execute the code, you have no class cast exception at the runtime. So at the runtime, line number 3 may or may not be executed, depending on what is the dynamic type for OBJ at this moment. Right? Because every time you run the same piece of code, you might have different dynamic type, right, for the OBJ. So this is just another angle to see what's going on here. Okay, okay, we're definitely going to do lots of examples, but before that, is there any question conceptually here? What we're doing here? So the instance, the instance of operator is closely related to under what circumstances am I going to be safe to do a typecast? They're closely related. Question?
Could you explain what fulfilled expectations means?
Fulfill expectation? Okay, maybe that's some part you missed. Okay, yeah, that's okay. Yeah. Let's say this. Thinking this way. So whenever, let's say B here, B is a subclass relative to A in the hierarchy. Every time you're creating a subclass, that means you're going to inherit everything from your ancestor or parents. So that means whatever that's expected from A, when you talk about expectation, it simply means what methods or attribute you can invoke on a context object of type A. So whatever you can expect on A is guaranteed they can be expected on B as well. It's simply inherited. Plus, there will be something additional you may declare and define in B. So when we say we can fulfill the expectation, so we can say B can fulfill the expectation of A because B is a descendant class. It just inherits everything from A by default, plus something additional. However, you cannot say A can fulfill the expectation of B. You cannot say that, right? Okay, good. All right. Good. Any other questions? All right. Okay, let's now do example, right? We do lots of examples, and then hopefully within 10 minutes, we can finish some example, and then we'll take a short break. Okay, let's see, one by one. Okay, for the first one. This is the example where we had our first class cast exception example, right? But now the difference is we are using instance of as a safety net before we do this class cast exception. But let's see exactly what's happening here, okay? So let's now highlight the important classes. So we have Jin, the reference variable. So first of all, we have the static type, students. Static type. And then it's created as non-resident students. So that's the dynamic type. All good. And then for now, just ignore line number 2 for now, okay? Let's look at line number 3. We're trying to do a typecast. And when we do this one here, again, you got to think about whether or not it's going to compile. And if it compiles, are you going to get class cast exception at the runtime? Is it going to compile? It is, right? Jin, statically, is students. From students, we are doing down to resident student. It's downward cast, right? Resident students and resident student over here. Okay, so it's a downward cast, first of all. It's a downward cast, number 1. And number 2, at the runtime. What's going to happen at the runtime, right? What we said earlier, this is actually going to run into class cast exception because the Jin here has the dynamic type non-resident students. Can non-resident students, the dynamic type, fulfill the expectation of the cast type? No, it cannot. Because this is not the descendant class, or this is not a descendant class of this. So it's not going to. So there will be class cast exception. Class cast exception if the cast is executed. Right? But we don't really want this class cast exception to occur. We don't want, because if that occurs, it's going to be thrown directly back to the console. We don't want to do that to the user, right? You want to avoid that as a programmer. So the way to avoid it is we got this line, which is here. Line number 2, right here. So this line here, it's making the typecast conditional. It may not be executed all the time. You will only be executed if the instance of operator is going to evaluate to true. You will only evaluate to true if the dynamic type for Jim can fulfill resident students. If you can, do the cast and guarantee you have no typecast exception. All right? And in this case, Jim instance of. Okay, if you think about this one here, we'll check if Jim's dynamic type, which is non-resident students, is a descendant of resident student, the right-hand side. Is this a descendant of that? No, false. If this is false, that means this part here is bypassed. That means the class cast exception prevented. So that's the biggest value of using the instance of. So the principle would be whenever you're trying to do some typecast, if you're not exactly sure about the dynamic type of that particular reference variable you're trying to cast, you better use instance of to be sure. All right? That's really the reasoning for that. All right, any question about this? All good? Okay. Okay, so this one here, guys, you can do it. All right, exercise. This one here, I'll leave it to you. Okay, you also see the answer on the slides. All right, let's now do a little bit more, like just try to do several instances of and really try to see what's going on here. All right, let's see. Okay, let's see what we're trying to do here, right? I got so many lines. I just want to evaluate the instance of. Let's get warm up first. Okay. I have this line here, which will give me some static type and dynamic type. I want to evaluate this reference variable on the left-hand side, and then I put different classes on the right-hand side. I want to see true or false. Guys, take 30 seconds. True or false? Hints for you, based on the first line, you should first of all identify where the static type and dynamic types are in the hierarchy. And then from there, you can try to check the definition of instance of with respect to different classes over here. Right? Just give it a try. If you're still not familiar with the instance of definition, that's okay. I just mentioned that not long ago. And this is some reminder about the definition, right? That's something you can definitely take a look at this stage, but later on when you write the exam, this is something you should be very clear about, okay? So smartphone over here is the static type. And Samsung over here is the dynamic type. And since we're trying to evaluate instance of, we want to somehow judge based on the dynamic type for Samsung. We want to judge based on the dynamic type for my phone, which is Samsung. In this case, we don't care what the static type is. All right? Conceptually, if I put my phone on the left-hand side, right here, to the instance of, it's going to return true if the dynamic type for my phone, which is Samsung, can fulfill whatever here expectation. What would that be? It should be Samsung, Android, smartphone, right? All the classes that Samsung can fulfill its expectation, everything, without the class cast exception, right? So this is something you also need to also get more used to. Okay, I'll just put it here. So these are ancestor of my phone's dynamic type. Meaning that the dynamic type can fulfill their expectation. Meaning that those classes, if they appear on the right-hand side, given that my phone is on the left-hand side, they should be true, right? So either Samsung, Android, or smartphone. So we got Android, Samsung, right? We got these two. We didn't have smartphone. That's okay. It's just not there, right? So that means these should be okay. Android and Samsung. These are the ancestor, and these are the descendants. Right? So if you want, I can put it there. Okay. Android and Samsung, right? Ancestor. Of course, you can put smartphone as well if you want to, but you can put it as an extra example. And then for descendants, Galaxy, iOS, just some other example. Anything else, basically. Galaxy and here and etc. All right? So the answer should be true, true, false, false, false. Okay? Any question here about this? Right? Again, whenever you're trying to do the instance of check, you gotta figure out, first of all, the dynamic type for the left-hand side. In this case, my phone, which is Samsung. And then on the right-hand side, it will evaluate to true if it's an ancestor for the dynamic type for my phone in this case. Because my phone can, the dynamic type can fulfill its ancestor's expectation. Okay? Now, similar, now let's now put the instance of use in the if conditional, right? So what I do is, you can see for each line, I got my phone, I got my phone here, and my phone here. Okay, let me just show you the structure. I got my phone here, I got my phone over here, and also I got my phone over here. And then I'm trying to cast my phone into something, and also into something. And before I do the cast, in order to prevent any class cast exception from happening at the runtime, I also try to do instance of check beforehand. You can see just the same class and just the same class. Right? That's the safest way to do it. All right? All right, let's see. And again, it's the same example here. So if we got smartphone here, static type, doesn't really matter in this case. But also we got Samsung, dynamic type, right? Okay. If I say instance of any of the ancestor class of Samsung, it should be true. That means I can safely cast. So now Samsung itself should be true. Galaxy S25 Plus should be false. And then Huawei Mate 40 Pro, for example, over here, it should be false, right? Good. So think about, so this will be actually true, and these will be false. What does that mean? That means this cast will be executed without guarantee, without any class cast exception. On the other hand, these two over here, if you executed these two lines, you would have gotten the class cast exception. But since you got an instance of check beforehand and that returned false, they will be bypassed. So for these two, bypassed. Class cast exception prevented. All right, questions? All right, good. Yes?
Is there a variable that can store the, like Samsung Galaxy S1 Plus, like the name of a class, for example?
What do you mean to sort the name of the classes?
So like, instead of manually checking all of them, you can, one by one, you can have them in like an array, and then you can go through a for loop that goes through the array and checks.
Not really, because in order to really do the instance of, you have to pass the name of a class. So I don't think you can simply pass a string, for example, right? Yeah, I think you're thinking a little bit more overcomplicated. I think normally you would just write like an explicit instance of check directly. If you actually want to, well, it could be that, for example, right? Okay. So let's say if you want to check maybe several possibilities, it could be that you can say maybe my phone. You can say instance of iOS, maybe, or, I don't know, my phone instance of Android. This is completely valid, right? So this one here, you can think about this one here returns either true or false. And this one here also returns true or false. And then you're combining them using the OR operator. Of course, exactly what logical operator you can use, it's kind of up to your judgment, right? Okay? All right, let's now move on to maybe another, okay, let's say 1, 2, 3, 4, 5. Okay. How about do very quickly, okay? So let's now see this, okay? Hierarchy here, and then let's say we have some reference variable SP. Static type is simply smartphone, right? Smartphone right here. And then we'll simply use SP, SP, and SP. And then we're just using SP as a context objects. So the expectation should be only dial and surf web. So these two should really compile, but not quick take. Doesn't matter what the dynamic type is. Doesn't really matter, right? So we know that this one should compile, this one should compile, but this one shouldn't compile. Even though the dynamic type is actually iPhone 13 Pro, but unless you do a cast. Otherwise, the static type of SP restricts about the expectation. Okay? Next one. Let's now change the static type of IP to be something a little bit lower. Rather than smartphone, let's change it to iOS. All right? So now we got iOS as a static type, right? And of course, if you check to see if iPhone 13 Pro can fulfill iOS, of course it can. So this variable assignment is valid. Now iOS is here, and then we're using IP, iPhone, right? And now what will be the expectation? So iOS is going to be FaceTime, surf web, and also dial, right? So FaceTime and dial. Does it have quick take? Which only exists in iPhone 13 Pro. No, it cannot, right? So that's why it should be this compile, but not this one. Okay, specifically the quick take exists in iPhone 13 Pro level, which is not part of the expectation for iOS. That's the static type for IP, right? So it doesn't compile. Let's go another one. Let's say this time we got the static type exactly the same as dynamic type. So now we can really fully exploit what's available there. So now we do static type. This, right? It's right here. So now in this case, we should really get quick take, FaceTime, surf web, and also dial, right? So all these will be okay, compilable. So the point is, by having different static type for the variable, it kind of determines about the expectation we have, which is something we did earlier. Just reaffirm. So good, and good. Okay, 2 more, and then we'll take a short break. This is an example about anonymous cast. Okay, just more example. Okay, so what we have is, let's see this. So static type for SP is smartphone right here, and then dynamic type is iPhone 13 Pro. iPhone 13 Pro dynamic type. Okay, so this is the static type. This is the dynamic type. And then you can see the anonymous cast we are having. We are trying to cast that into iPhone 13 Pro. That's what we are trying to do, right? And don't forget, we got the surrounding parentheses, right? So the cast type is iPhone 13 Pro, which just match the dynamic type, which is okay. That's kind of the lowest you can cast down to. If you cast any lower, you cannot fulfill, right? So this is also the cast type. Okay, I'll leave exercises for you guys to think about why this cast over here, number one, compiles. Number two, it does not have any class cast exception. Make sure you know how to judge that and also explain that. Okay, now, will this method call compile? How do we judge it? This is a method call. Whether or not it will compile depends on whether the method is part of the expectation of the static type of the context objects. What is a static type for the context objects? Because it's a cast expression. So we don't really look at the variable being cast. We look at what's the final outcome of the cast. All right? So what you want to think about is this part over here is a typecast. Typecast of static type iPhone 13 Pro. So given that the static type is iPhone 13 Pro, of course we can call dial, FaceTime, and QuickTake, right? They're all defined right here. Right? So there are three things you want to double check for yourself when you study this page. Number one, why do all the casts compile? Number two, why is there no class cast exception for all the three? Number three, why do all the three method calls compile? These are the three things. Okay. Okay, one more, and then we'll take a short break. Okay, the final one here. Let's see. I think this one might be just similar, right? Okay, let's we can take a quick look. I think this one here is just about you creating some students and then you say instance of, okay, that one there, nothing new. We don't need to do it. So I think that's one you can also try. But I think the main point is, since I draw the diagram here, so when you actually try to do this anonymous cast over here, also try to visualize the cast as well as an alias, like what we did earlier. I think that's part of the exercise for this page, right? But this is just an anonymous cast. So I can just show to you for this anonymous cast over here. So this is a cast of static type resident students. So that's why you can do set premium rate. However, whether or not it's going to run into class cast exception, it's prevented by this instance of exactly over here, right? So I think the main thing to show you here is about the anonymous cast. Okay. All right, question. So now we are done with basic about typecast and instance of. We'll take a break that you guys deserve. After the break, I would like to talk about inheritance and call by value. All right. Get your iClicker ready, please, and then we'll take a short break. All right. So before the break, we basically cover everything up to and including slide number 76. Okay. So now we're going to start with slide number 77. Just before that, let's review something very quickly. Call by value, right? Which is very important. Okay. Of course, you can refer to the earlier lecture, but just for today's purpose, can anybody summarize what call by value is about? Anybody? Want to give it a try? What do you want to try? I'll let him do first, yeah. Okay, go ahead.
So technically, when we say call by value, when we call using a primitive, we have technically we have a copy of the thing. We do not point to the address.
Okay, you say a copy. So a copy of what?
So let's say you have a variable, and then you are passing that variable for a method call, right? And then while invoking that method call, when that method will be executing, that will have a copy of the value of that variable.
Yep. Basically, right? Yeah, basically we're saying that parameter is going to be a copy of the arguments, right? Very good. I'll just make it sound a little bit fancier, okay? So let's now talk about it, right? It's very important for you to visualize the call by value. So call by value, and we're going to use it. Call by value. So whenever you have a method call, so let's say you have, some class C, for example. And then you have some method m, I just wouldn't put a type. And then we have some parameter with certain type t. And then let's some parameter p. Okay, it's param. Okay, and then you have stuff over here. Okay, so that's about the caller, sorry, the callee side. Okay, oh, sorry, I can draw better. So this is a callee side. Okay, there we go. Okay. Okay, good. So that's callee. And in the caller side, we actually try to say maybe C and then some objects, new C, for example. And then we are trying to declare some arguments, which will be primitive or reference type, doesn't really matter. The way we handle call by value between primitive and reference are just the same. And then we can say obj dot m. And then we simply pass the arguments, right? So this will be the caller side. Of course, I'm trying to oversimplify well, not really oversimplify. I'm trying to simplify this scenario a little bit, but you guys should really review the call by value, okay? So call by value simply says that, as your fellow student pointed out, exactly right. So before we try to execute method n, there will be some implicit assignment that's to be done first. That's beyond your control. So argument here and parameter over here, and then you can see right here. So call by value is actually going to do some implicit assignment. Paren is assign arguments. Okay? Now you should be very sensitive when you see variable assignments. What if there is some inheritance hierarchy involved between paren and arguments? For example, paren may have the static type students. Arguments may have the static type resident students, in which case this call by value is going to work. On the other hand, paren could be iPhone 13 Pro statically. Argument could be a smartphone static type, in which case the call by value is not going to work. So this is a very nice connection to go from call by value and combine that with inheritance. And now we're going to talk about if you're trying to make a method call, which is so frequent. You got to do it all the time. So when you're trying to make a method call in the context of inheritance, how can we judge? Again, if things are going to compile, if it compiles, what's going to happen at the runtime? Are we going to run into class cast exception? All the discussion again. All right? So today I will do something a little bit light, not very much. Let's see. I got about 15 minutes. I'll do a bit of this introduction, go over some example, and then we'll do another more advanced one. Okay, and then we'll finish the rest on Tuesday. Okay, let's see how far we can go. But just make sure you kind of understand about the call by value. It's going to be paren assigned some arguments, right? And then the critical question is, what if these are reference types and there is some inheritance hierarchy in the context? Inheritance hierarchy in the context. So that's exactly the essence about making method call in the inheritance. We'll see that, okay? All right, so if you look at the slides, I'll show you a little bit slideshow, a little bit, and then we'll come back to the iPad. So let's say, so now finally we got a different class, right? Student management system, okay? So we got students, we got students, we got resident student, we got non-resident student. So now we got a fourth class, student management system. So this is the place we are trying to hold a collection of students, okay? So here I'm declaring an array of type students. I call it SS, students, okay? And I have, and then I see, okay, that's one. Let me just go to the iPad directly to show to you, but you can go over the rest of the slides. Okay, let's see this. So we got student management system here. We got a single array, SS. And we got some mutator called @resident students. Here, the parameter type is resident students. We got another one called @NRS. The parameter type is non-resident students. We got another called as students. The parameter type is students. You can see I'm trying to show to you what are the possible parameter types. All right? Just understand the structure over here, and then I'll help you with understanding what's going on by answering some questions. And then we'll do some exercises together. Okay, let's start with the simple one. Okay. Let's now, you guys can tell me, what's the static type for each element in this array, statically? So let's say SS is of length 10, for example. So what is the static type for SS at index 0? What is the static type for SS at index 1? All the way to what's the static type for SS at index 9? How did you know?
Because in the I2 declaration.
Yes, exactly. Static type, not tricky at all. Just look at the declaration. Dynamic type, more complicated, which we're going to do on Tuesday. All right, good. It's going to be, okay, for SS0, the static type is going to be student. I'll just put S, okay? Also, for SS1, the static type just the same. And all the way to the last one there, the static type is also student, simply because the student here. This is indeed the static type of each elements in the array. And a little bit look ahead for Tuesday. Remember polymorphism. Polymorphism tells us that if you actually declare the static type to be certain class, what can be the dynamic type? Any of the descendant classes. So that means each element in the array, given that their static type is students, dynamically what can they be? Can be resident students or non-resident students. Depends on how we set it up. That's something called polymorphic collection or polymorphic array. So that's something we're going to talk about on Tuesday. But for today, we'll do something a little bit more fundamental. Okay? So question number 1 is really about the static type for the array that we declare. Right? Just understand for line number 2, we're declaring an array of certain size, but each element in the array has just the same static type. Okay? Question number 2. Let's look at this method here, add rs, right here. Okay, I'm going to highlight it. Oh, sorry, not here. All right, so this particular method here, you can see there's a line here. Does this line compile? Yeah, go ahead.
I'd say yes, because a resident student meets the expectations for a student, so it's able to...
Ah, pretty good. Okay, let me make it slightly more complete. Okay, that's exactly right. Okay. So this will compile, and I'm pretty sure most of you actually know why. So if you look at RS over here, has the static, right? What's the static type for RS? Resident student, because it's declared here, parameter, right? Resident students. And also, if you look at what's the static type for each element in the array? Students. That's a question for, also the answer for question 1. Now, we're going to judge to see whether this one should really compile. Can this fulfill expectation of this? Is this a descending class of that? Yes. So it will compile. All right, that's very important. We're talking about compilation. So here, this might be something you're seeing the first time. You're seeing some array element on the left-hand side. It might appear on the right-hand side as well, but the principle will just be the same. Figure out what is the static type for that array element, which you can look up to how the array was declared statically, and then do everything else the same way. All right, now here's a question. And what I just reviewed with you guys might help answer this last question here, okay? So we are asking, under what circumstances can the following method called be valid or compilable? So let's say let's say I already created some SMS. Let's say SMS over here is some objects of static type student management system right here. Okay, let's say student management system. So I'm calling the addRs method here. And then I'm passing some O, which is arguments. What can the what are the conditions? Conditions of arguments O that can make this method call compilable. Compile. That's really the question. Okay, very, very critical question. And the hints will be call by value. Anyone? Yeah, go ahead.
Any object who is either resident student or a descendant of resident student?
Yeah, any object of static type that's a descendant class of resident students, basically. All right? And the reason is call by value. So you can see that we are now let's see this. Add RS is the method right here. We're making a method call. So let's now think about call by value. Right here. So call by value tells us that before we execute any line in this method here, there will be some implicit assignments to be done, which will be the parameter RS assigned to argument O. We already know the static type for RS is actually resident students. So what can be the static type for O here? Any of the descendant classes of resident student. In this case, only one choice, just RS. All right? Okay. So the answer is O's static type must be a descendants of, okay, I'm just writing here. Sorry. Just write it here. Write it. Must be, oh, I'm so sorry. Okay, it would be tricky for me, but I'll just put it here. Okay? It's a descendants of the static type of the parameter, which is resident students. Okay? Any questions about this? It's very fundamental to see whenever you have a method call and then the argument here that's being passed, the argument itself has a static type. The corresponding method and the corresponding parameter also has a static type. In order to see if the call by value is really going to work, you got to consider the implicit assignment right here and see the order, right? Let's now do example. Okay, we got about 6 minutes, should be good. All right. Guys, grab a piece of paper and then we'll go over the answer. This will be the last exercise we'll do today. All right? I'll set it up for you. Okay, I'll give you guys time. We definitely have time. All right, so let me remind you very quickly. So you have basically a student array, and then we got add RS, add NRS, add student with different parameter types. That means call by value might appear in different contexts. And here we are trying to create S1, S2, S3, RS, NRS with different static types and also different dynamic types. And then we are creating some student management system, SMS. So we're basically using this SMS as a context object, which you will see, SMS. And we're calling different methods. Okay, why don't we call it that quickly? Add RS is called right here. As students, is called right here. I didn't really put add NRS, but it will be something similar, which you can also try yourself, right? I'm just trying to show you different possibility. And then the argument here, I simply put different variables that we declare right here. And your task will be, for each line, determine whether or not it's going to compile. Okay, take 2 minutes. And of course, the key really is to understand how the call by value is going to work. And once you understand about the call by value, you want to consider the corresponding variable assignments, and then what's the rule for that substitution to work, which is something you should know for tomorrow's test. And some reflection question for you, all right? You will think that the question is, based on the answer that we're going to go over, whenever you're trying to design the parameter type for your method, let's say there's an inheritance hierarchy going on behind the scene, right, in the context, how should you choose the parameter type? Should you choose a parameter type that's rather high in the hierarchy, or should you choose some parameter type that's rather low in the hierarchy? It's going to make some difference. There's no right or wrong answer, but it's really about what you really need. That's more like a software design issue, okay, which you have to worry about in the 3rd year a little bit more. Okay. All right, another moment, and then we'll go over the answer. Okay. Is this going to compile? Yes or no? No? No. Okay. What's the trick? Add RS has resident students, meaning that it's going to be RS is assigned to something, which is the argument right here. This is statically resident students. What can this be? Descendant classes only, which is only resident students. That means only this one here is going to work, because RS statically is resident students. All the others are simply either students or non-resident students. They are simply not descendants of resident students, right? So if you look at the answer, it's going to be like that. All right? So that means the add RS is rather restrictive in terms of accepting the arguments, because only argument that has a static type, being the descendant class of resident students, right here, can be accepted. All right? How about here? Auto compile? How come? Yeah, pretty good, pretty good. Let me make it a little bit more complete. Because at student here, parameter is students. That means this will be put on the left-hand side for the call by value. Given that S statically student is already on the top of the hierarchy, all the classes will be descendants. That means all these classes, all these variables has the static type, descendants of that. So all good. Okay? So you can think about the student here is already the top of the hierarchy. All right, it is so important, guys. So make sure you review this before next Tuesday. Next Tuesday, we're going to finish the final bits for the inheritance, which is about polymorphic collection. All right, I'll see you tomorrow. Thank you.